I'd like to share with you some ideas about biomedical science, its strengths, and some of its weaknesses. And we do that in the context, if we can, of the goals of the Society for Scientific Exploration. The second one being that we will seek out and explore and explain those hidden worldviews, restrictive worldviews, and hidden theoretical assumptions that get in the way of ordinary science, and that also tend to take theory and bring it into dogma. That's part of the mission stated for our organization. And the strengths of biomedical medicine were illustrated in the New York Times this morning. I don't know how many of you have read it, but there was a first in biomedical science right up the road at San Francisco Medical Center, where a young man was dying in a coma with a fever, and all the tests could not be done, and they decided to do something they had not done before and identified the DNA of the bacteria in the young man's tissues, were able to initiate treatment, and he's doing just fine, thank you. So I think we can see the notion, all the technology, we're all aware of the strengths. And we can kind of imagine that started back in the early 20th century, in 1900. The leading universities, med schools in the world were in Vienna and Berlin. And our American people went over and studied there and brought that information back to Harvard and Johns Hopkins and spread to all the medical schools and became the standard. We shortly thereafter passed laws in this country, and that is that medical schools had to be attached to universities, and that was to, again, to maintain that scientific rigor that we needed to be sure that people were not dying unnecessarily from quacks. And so that didn't grow well. We got peer review after that. And we all know that to get grants, we need peer review, that we will be using the scientific method empirically and properly, and to get published in journals. The journals take great pride in saying that they are peer-reviewed journals. And so that science is here to stay. It's wonderful. But let's now then step back and look at maybe some of the weaknesses of that science. And sort of like this man on the tightrope who, in the paradox, holds up the end of the tightrope with his hand as he walks the tightrope. It's that kind of self-referential paradox that we'll be looking at. And you know, back in 1900, I suggest there were two seeds that were planted that started to then would gradually develop into the weaknesses of this biomedical science. And I might say that the first of these was mathematical. Bertrand Russell was busy finishing up his perfect mathematics, the Principia Mathematica, with his mentor, Alfred North Whitehead. And it was ready to go to press. And he suddenly realized that it contained an error that permeated the entire work from front to back. And he expressed that error in set theory like this: a set of all sets that do not contain themselves both cannot and must, paradoxically, belong to that set. And he stated it in the vernacular for us: what man shaves the barber in a town in which the barber shaves the men who do not shave themselves. And so that it went back to the ancient Parmenides and Zeno, all the ancient Greek, the liar's paragraph, the liar's paradox. Then people didn't like this. They wanted it to go away, and they tried everything they could do, and even Whitehead wrote an axiom that says you can't think that way. The problem was that you can think that way, and so it didn't make it quite go away. Along comes 20-some years later a young man, Kurt Godel, University of Vienna, and he wants to make that paradox go away real bad. He's going to get his reputation that way. And he works and works, and in 1931 he comes out with a paper that later won him the Nobel Prize and actually had proved the opposite of what he set out to prove. In his incompleteness theorem, he demonstrated to us that that paradox will never go away. And this was added to later by Alan Turing, the later inventor of the computer, who pointed out mathematically that not only were there problems that mathematics could not solve, there were an infinite number of problems that mathematics and logic could not solve. This went further with Lorenz, who was trying to predict the weather with computers and this highly complex system that remains unpredictable today for a great deal of it. And he programmed the computer a little bit off, and the computer whirred and made up its own mathematics. And this began the notion of emergent theory coming out of chaos, of highly complex systems that events emerge that are unpredictable by ordinary science or from what came before them. So this whole idea of emergent phenomenon, I wrote about it once in a paper on miracle healing. Is it miracle healing an emergence out of chaos that is not measurable by science? It's an interesting idea. The second now seed that may have been planted in 1900 for the weakness was our friend Max Planck. And he was sitting at an outdoor cafe in Munich and talking to his friend Heinrich Rubin, and they were trying to figure out the black body problem, which all the physicists at the time were trying to do. And he had a sudden idea that if he entered a constant, which he called H, which would be the smallest unit of energy or matter that could exist, that he solved the problem. He later won a prize for that also. And he wrote it on a postcard, and it's in some museum in Europe. And we see that, we remember now that, that the double slit experience that Dean Radin talked about this morning came out of that, and we came out with 4 ideas. Amit Goswami has enumerated them for us. Quantum particle can be in 2 places at the same time. A quantum particle can be here and appear over there without traversing the intervening space. A quantum particle cannot be said to exist in space-time until it is observed. And quantum particles can affect one another at a distance instantaneously. And now, last July, we all celebrated the Higgs boson with the people at CERN, and they're telling us paradoxically that something can come from nothing. And the universe, we could postulate, is created from nothing. Maybe that's what existed before the Big Bang. And now we have quantum computers. And one of the differences in quantum computers is a paradox. And that is that in our ordinary computers, the computations depend upon the multiple bytes being on or off. In a quantum computer, it relies upon some of the qubits being both on and off at the same time. And so I'm just bringing us a little bit up to date that to proceed with these seeds. Yes, here is the picture of the quantum computer that we can see how confusing that can be. Now it looks like this paradox is here to stay. We can look at that. We blink and we see 2 faces looking at one another. We blink and we see a candlestick. And neuroscience now tells us that happens with a wave of electrical energy in the brain. It's not just some local. We don't sit and measure it and say, well, this and that point and how far apart. It clicks. And that's being brought more up to date now by a recent book by Eric Kandel about viewing art and the neuroscience of viewing art. This notion of the highly complex nature of our thinking. Now, this fellow here seems to me kind of grumpy, and I've decided that he must be the chairman of the peer review committee. And he does not like what I am saying right now. And he tells me that I have to take in complexity theory and boil it down to ordinary science so that it makes sense. And he will not allow me to get a grant because I want to say that I want to include the paradox and the in complexity and emergence. I want to include that in my method. Not just have it as a goal to explain it, but to include it in the method. And he says, I cannot do that. And he doesn't seem to realize that when we study randomness, as soon as we bring order to randomness, it is no longer random. And so how can we include randomness in our method? Keep it there, just like when the heliocentric notion of the universe showed up back in the 17th century. And so we don't have to go far. People like Langmuir, John Ioannidis, Dr. Schooler up at the University of Washington have all pointed out the inconsistencies in biomedical science, mysterious decline effects and verbal overshadowing kind of words that they use. Yes, and you know, I sort of laugh when I read the New York Times a lot of days because there's an article on the front page that says the study we did last year is no longer true, stop taking your statins, and now another study is true, and then on the third page is another study, and I say, how can I believe this study if I couldn't believe the other study? There's a weakness there in biomedical science. And so let's go on and see if we can look at some things that have come out of it that are kind of interesting and maybe hopeful. Freud came along in 1900. That's when he published The Interpretation of Dreams, and he brought in that unconscious. And I sometimes think he was the first complementary and alternative practitioner in the modern era because he was treating the physical symptoms with psychological, and they were not logic, they were not measurable phenomenon. There was a conversation. She called it the talking cure. And the paralysis disappears, not because you measure it or find some scientific study that shows that if you say this word, because it simply coalesces from the unconscious to the consciousness of a human being. And so that puts us in a place of looking a little closer at phenomena. Now, when the complete and alternative medicine became totally respectable in the United States in the 90s, when the National Institute of Health established that department, and the first and founding chairman of that organization said, we are going to prove once and for all whether these alternative medical practices work. And the New England Journal of Medicine and the Journal of the American Medical Association both came out with heavy, heavy editorials saying that there is no such thing as alternative medicine. There is only that medicine that is proved by science and that medicine that is not. And what do we have now? We have complementary and alternative medicine in almost every medical school in the country, lots of grants for it, lots of activity going on. And when asked, there was a lovely new book out, an article in Atlantic Monthly by David Friedman, and he went and interviewed alternative healers in university centers, and they all agreed that the evidence that of all the research that has been done, thousands of studies, it's hard to find a study that has a statistically significant outcome. So then he asked them at the end, the experts, he said, well, why do you keep doing this? And they said, because we kind of think it probably works. And you know, I love it. They smuggled it in. We smuggled in the paradox, and it's being used. And it's just kind of marvelous. And, if you ask the average ordinary mainstream biomedical scientist or practicing healer, they will say that evidence-based means the old meaning of science, that it's statistically significant, 0.05 factor, and so that, but if you ask alternative practitioners, and I've asked a lot of them at various meetings, well, we say, we can fudge that a little bit and say that something is promising, partly because it's not harming anybody. And these departments all over the country are flourishing. I think it's wonderful, but again, just to point out that we had to enter the paradox in order to proceed with the treatment, and the public in many ways demands it, and so do some of the benefactors. Now, the other thing that happened in 1900 about this is that a man named Santiago Ramon y Cajal, a neurohistologist, one of the first ones, demonstrated the synapse and the neurons. and he was an artist also, and this is a drawing of his from looking through the microscope. And it's sort of interesting to me that at the same time it was when Edmund Husserl published his first volume of logical investigations and pointed out perhaps what is to humans the most serious self-referential paradox of all, and that is the only way we can study the mind is by using the mind. And here we are in that paradox, as I say, it's with us, and it's nice that we're able to fudge it and say, hey, I think so. There's hardly a healer around who hasn't someday had an intuitive notion, and Carl Jung would call it synchronicity, but anyway, so that we now have, we now know that we have hundreds of billions of those neurons in our brain, right? And we know that each one of those has tens of thousands of connections to others, and many of those connections go around in loop-de-loop, and Hofstadter's latest book is called I Am a Strange Loop, and he feels that consciousness is itself that loopity-loop of the brain that comes back on itself in an infinite regression almost. And so it looks to me like it's all here to stay. There's Jeffrey Sattenover has a book that just came out called The Quantum Brain, and he goes into these ideas in detail about what's happening at the synapse. He and Dr. Eric Kandel both demonstrated, the one who does the images of looking at art and the massive brain function that occurs as you look at art and see it as image and perhaps metaphor. And are saying that there's a delay at the synapse that's been measured in a guy named Libet years ago, and we know that there are delays along the way as those various connections are made, and especially in the speed of the loop-de-loop and how long it takes us to grasp that, the idea there, but that it's too fast to be explained by our ordinary proteins that transport subatomic particles across the membrane, the neuropeptides, and also some ions that carry that it's too fast. And a Czechoslovakian man, what's his name, Reines, and he has come out with a lovely paper that outlines a potential way to look at that in a flow chart that would help us to understand. So now then, I'm just going to I want to raise the question with you in the sense of the goals of the Society for Scientific Exploration that we talked about earlier. And could it be that the reason that complexity looks so weird to us, an emergent phenomenon, and seems so, and we're trying to bring it back down to science to understand it, but the reason that it looks like it needs a resolution is because we're looking at it through a rational lens. We're not doing it through the unconscious, the way sudden apparitions, and so that lens then allows us to view it from the point of view of ordinary rational logical mathematics. And that the reason quantum seems so weird to us, especially when it comes to healing, we have to try to reduce it down to ordinary science. What do we do with it? But anyway, just to say that, could it be that, that this aspect of modern biomedical science, that lens that we use to look at it with, that is itself a restrictive worldview and a hidden theoretical assumption called scientism. And so I'll leave with that. We're ready for questions. I'll just tell you that I feel like that dandelion in the midst of a big field of wild garlic. I will try to, if there are questions, I will try to answer them unequivocally, always holding in my heart that in a quantum computer depends upon some of its qubits being both on and off at the same time. Thank you. Are there no questions?
Would anyone want to raise their hands?
Then I'll just mention something to you. I think this will be kind of fun and we'll enjoy ourselves. But I was at an Institute of Noetic Science meeting in Palm Springs some years ago, and the opening speaker, in order to emphasize the serious and the scientific nature of the meeting, said in her opening speech, remember the words of the great poet Rilke, who said, love the questions, live the answers. And when the open mic came, I had to get up and say, I hate to say this, but Rilke did not say, love the questions, live the answers. He said, love the questions, live the questions. And it brings to mind myself that if we use that poetic notion, the poetic aspect of it, we probably would, in the country, be taking half as many pills as we take every day if we loved the questions. Thank you.